Welcome back to P1. Today we are looking at functions unit 2.3. So a function is a relationship, a mathematical relationship that maps each value of a set of inputs to a single output. Now, when we're talking about inputs, we're talking about the domain. These are in general my x values, and the outputs or the range, these are my y values or my f of x values, and the roots are where we hit the x axis, okay, when y equals 0 or f of x equals 0. Now, if I have a function like this, as I was saying before, it will map my domain to my range. So looking at this one, if I got a domain where one of my values is 3, then what I'm doing is I'm putting 3 into my f of x. So this would be 3 squared minus 3. So that would be 6 for my y value. This is part of my range. Look at the next one, f of 5. So that's 5 squared minus 3. 25 minus 3 is 22. If I'm substituting minus 1 for my x, then that's minus 1 squared minus 3 to be minus 2. And then final one here, substituting half squared minus 3. Half squared is a quarter minus 3 would be minus 2 3/4. Okay, or I could have written that as an improper fraction as 11/4. And this is the idea of what's happening with my function. It's just taking values of x and converting them into that y value, that f of x value. Now let's have a look at the type of question you will see for these functions. So we've got the function f is defined as f of x equals x squared minus 4x plus 5. Okay, now for part A, find the values of, so f of 3. So I'm just substituting 3 in. So I've got 3 squared minus 4 lots of 3 plus 5. So 3 squared is 9, 9 minus, I'll do this as extra steps, of 9 minus 12 plus 5. And that will give me 2. And that's how I find f of a value. Okay, substituted in 1.5, same thing, 1.5 squared minus 4 lots of 1.5 plus 5. And there's nothing to say that we have to do this in our head. You know, you're more than welcome to use your calculator here. And then the final one here, f of 6, we'll work these out separately. So 6 squared minus 4 lots of 6 plus 5 should be 17, and f of 2 is 2 squared minus 4 lots of 2 plus 5, and 9 minus 8, 1. So f of 6 minus f of 2, 17 minus 1, so that's 16. Let's look at part B. I'll take a fresh page for this. So in this one now I need to write it in the form x plus p squared plus q. So this is completing the square. So x squared minus 4x plus 5. This is my f of x. So completing the square, x minus 2 squared minus 2 squared plus 5. So we got x minus 2 squared minus 4 plus 5, or x minus 2 squared plus 1. Okay, and now you can see that P is negative 2, Q is a positive 1. Let's have a look at part C now. Now, when we see this hence or otherwise, now that's basically telling us that previous part of the question or one of the previous parts will make it easier to answer this part of the question. So the previous part of the question, we had x minus 2 squared plus 1. That was what my f of x was. Now it's asking me why f of x is always greater than 0. Well, you can see here this bracket is squared, and because it's squared it's always going to be greater than or equal to 0. And then this is positive 1, which is obviously greater than 0. So the minimum, the smallest value we can possibly have here is 1, which is greater than 0. There is no smaller value than that, because even if I substitute negative value in here, like minus 10 plus 2 minus 12, but when I square it, it becomes positive. So the smallest value this whole bracket can take when it's squared is 0. Okay, and 0 plus 1 is 1. And that's all I need to do now with my explanation. So I would say that, squared terms are always greater than or equal to 0. So minimum value is 0 plus 1, which equals 1. And that should be sufficient there. Now I'm going to give you a few of these to try. If you're stuck on any of the questions, just skip forward in the video to have a little look at my explanations. So a nice easy question here. So a f of 4, just substitute 4 in. 16 minus 3, 13. Let b, f of minus 3, so again, substitute minus 3 in. So minus 12 minus 3, minus 15. Look at part C, this is g of 5. Substitute g in, so 2, 5 squared, 2 lots of 25, which is 50. Part D, f of 1, so 4 lots of 1 minus 3 is 1. Then we want h of 3, this is 3 minus 1, so root 2. So f of 1 plus h of 3 is simply 1 plus root 2. And I would leave it as a surd rather than changing it to a decimal, unless the question asked otherwise. So in this one now, f of a equals 6, so f of a equals now a squared plus 5a, and that equals to 6. Yeah, so we substitute a in because that's what's here, and then it has to equal 6. So this gives me a squared plus 5a minus 6 equals 0. This looks like it's going to factorize, so we want a plus 6 minus 1 So a is negative 6 or a is 1. And you can check both of these out, can't you? You know, if I substitute these into my equation, 1 squared plus 5 lots of 1 is 6. And substitute the negative 6 in, negative 6 squared plus 5 lots of negative 6. So we have 36 minus 30, which is 6. So it is exactly how I expected. Okay, number 3. So on this one, the first thing I need to do is complete the square. So x squared plus 6, x minus 3. So that gives me x plus 3 squared minus 3 squared minus my 3. So x plus 3 squared minus 12. Hence, or otherwise, find the minimum value of f of x and state all x and y intercepts. So the minimum value happens and can only happen when this bracket is 0. So when this bracket is 0, x needs to be negative 3. And when that happens, f of x will be negative 12. Okay, so to make this bracket 0, I need x equals negative 3. And when I substitute x equals negative 3 into this, I get negative 12 as my y value, or my value of f of x. Now, to find out where it hits any of my axes, it's a positive x squared, and it's in the negative, so it's in the fourth quadrant, so it's definitely going to hit the axes. So I can see that it's going to hit the y-axis at minus 3, get that from the original equation. So one of the coordinates is 0, minus 3. This is the y-intercept. And then looking at the x-intercept is obviously when y is 0, so that is when x plus 3 squared minus 12 equals 0. So x plus 3 squared equals 12, x plus 3 equals plus or minus root 12, x equals minus 3 plus or minus. Now root 12 can be simplified to 2 root 3. Okay, so that's my 2 x-intercepts here. If I was going to write them as a full coordinate, which I might do in an actual exam, then I would probably put it would be minus 3 plus 2 root 3 and minus 3 minus 2 root 3. So looking at this one, it looks off-putting initially, but actually if you square x cubed, you get x to the power 6. X cubed squared is x to the power 6. So this is just a quadratic. So let's go about solving it like we would any other quadratic. So in this case we've got x cubed and x cubed, and it's going to be 8 and 1, I'll be positive that would be negative. Now another way of approaching this could have been let y equals x cubed, and then you've got y squared minus 7y minus 8 equals 0. And obviously you end up with the same answers. Like that, which we're solving. So you can start like this way, and then you substitute your values back in, or like I did initially, you can do it in one go if you spot that you're comfortable with doing that. Cube root of minus 1 is minus 1, cube root of 8 is 2. So there's my answers, and I would get that whichever way I approach this question. Okay? So final question, number 5. So we've got a function here again, it's defined 3 to the power 2x, we got 3 to the power x in there. It looked confusing. Let's use that substitution and make our life a little bit easier right from the start. So when I see this 2x and x, that means that this is the squared term, x times by 2, this is the single term. So just so that you know 3x squared is the same as 3 to the power 2x. Remember your rules of indices there. But what we'll do on this one, just to make it a little bit easier, we'll start by going let y equals 3x. Therefore then g of x is equal to y squared minus 28y plus 27. Okay, this then makes this really easy to solve. So it's got to be 1 and 27, and they're both negative. That means that y is equal to 1 or y equals 27. Okay, then substituting back in, we get 3 to the x equals 1 and 3 to the x equals 27. Now this is actually me solving it all the way to b, but we did have to leave it in this form for a. So if I at this point jump across here, I'll write this bit in black so you can see. So for a, my final answer then would be 3x minus 1 and 3x minus 27. Okay, then part B is about me solving it, so I can carry on and finish this. So 3x equals 3 to the power x equals 1. So this one, x has to be 0. Anything to the power 0 is 1. And then to solve the second one, if you don't spot it, you need to write the second, the 27 is 3 to the power something. So going through your 3's, do 3 times by 3 is 9, times by 3 is 27. So that's 3 times. So x there is equal to 3. And that's it solved. Okay, so you work out what your base value is, so they're both the same, and then just multiply by that value until you work out what the power is. Hope you found this useful. If you did, hit a like, hit a subscribe, and I will see you for the next lesson.